Now technically I think I would do this as B and this as A. Because if we sketch the graph first, it's going to be really easy to see from our sketch. Is it opening up or down? What the vertex is. So I think it is more helpful to start with the graph. Now when we start with the graph, the very first point we're going to grab is our vertex. We're going to say, oh, this one has a transformation. I noticed in the homework assignment there's some people asking questions about the word transformation. Transformation is just a word to describe has it moved left or right or up or down. And in this case, this one has moved 3 to the right and 1 up. That will be our vertex. And the A value of this one is 1/4. So that means you would go over 1 up 1/4, then over 1 up 3/4. So if I just draw that with a little dot, 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 over 1 up 1/4, over 1 up 1/4, can you see that you could label a point here and here? This would be 4, 1.25 and 2, 1.25. Because I've gone from 1 and I went up 1/4. Then my next point, I'm going to go over 1 up 3/4, over 1 up 3/4. I guess I didn't strategically do this with how I labeled my points. But if I went up 3/4, are you okay that 3/4 is 0.75? This point here is going to be 1, 2, and this point will be at 5, 2. And now we can draw our parabola U shape going through that. Now, 1, 2 is a nice point, but 2, 1.25 decimals not quite as nice. You can always check if you're using the shortcut over 1 up to graph. You can always check your shortcut by plugging things in. What happens when x is 1? I plug that into my equation. 1 minus 3, -2. -2 squared, +4. What is +4 times by 1/4? Well, it's 4 divided by 4. It will be 1. And then we would have 1 plus 1. It's 2. I'm feeling good about this. Okay? We can also do that for important points. Like this is going to have 0, something. That's going to be my y-intercept. How do I find that? Well, I could go over 1 up 5/4, because that would be the next one, and count it. Or I could just plug in 0 into my equation. 0 into my equation would be 0 minus 3, -3, squared would be 9. 9 times 1/4 would be 9/4. We have to add 1, which is the same as 4/4. How do you add fractions? You need a common denominator. We are going to find out that our y-intercept is 0, 13/4. And maybe you can figure this out as a decimal. This would be 3.25. Maybe I haven't drawn it very good on my scale. That's okay. Okay? Something that we make sure that we have on our graphs is arrowheads on the end. I make them super big right now because they were small before. Because our graph does go up forever. So we've sketched the graph. Once we've sketched the graph, these questions become easier to answer. Which way does it open? Up or down? Up. What's the vertex? 3, 1. The axis of symmetry, let's draw it on our graph. That's the straight line up and down that's dotted. Do you remember from grade 10 the equation of straight lines? Straight line equations are always, if they're vertical, x equals. They're x equals line because every point on that dotted red line would have an x coordinate of 3. The vertex is one of those points. It has an x coordinate of 3. It's 3, 1. This point is 3, 0. This point up here, 3, 10. The x coordinate is always 3. That's why vertical lines, their equation is an x equals equation. Which your brain, the main vertical line that you're used to is your y-axis. Right? This is your y-axis. That's the main vertical line that you're used to. Your brain wants to write vertical lines as a result as y equals. Because you think of the y-axis. That's wrong. Okay? But that's what your brain is going to do to you. Your brain is smart and dumb at the same time. It's a wonderful, frustrating thing. Your brain is always looking at other things that you know. Right?
Sorry for the interruption. Grade 9 students with the last name that starts S to Z, please make your way to the library if you need a picture retake. That's grade 9 students with the last name S to Z. If you need a picture retake, please head down to the library.
I have a brain story for you. Okay? This is my brain playing tricks on me. Okay? In 23 years ago, I lived in South America for a year. And while I lived in South America, everybody spoke Spanish, except for my friends who were also from Canada. Okay, they could speak Spanish and English. Okay, so I lived there for a year. I come back, and my brain starts playing tricks on me the first week that I'm back, because when I was in Bolivia, I knew I had to speak Spanish to everybody except for my friends. Okay, so my brain made the following pattern. If someone is Caucasian, they speak English. If someone is not Caucasian, they speak Spanish. So I would come back, and I would have friends who, they're originally from the Philippines. I couldn't speak English to them. My brain would go to Spanish, and I look at them, and I'd pause, and they're like, what's wrong with you? And then I would be somewhat shocked when they spoke English to me, because my brain was like, this isn't supposed to work this way. You are not supposed to be able to speak English. You are only supposed to be able to speak Spanish. And your brain would do it very, my friends from Hong Kong, from China, they are obviously not from South America. It's pretty obvious. But my brain would still go, this is Spanish. Okay? And when I played soccer, because I played a lot of soccer when I was in South America, I couldn't ask for a pass in English when I came back to Canada. I would be like, and it was just like, it took a while for my brain to switch. And my brain was being stupid. It was pretty obvious. It should be pretty obvious that if I would come up to Bassam, he doesn't speak Spanish. Do you speak Spanish? No. See, he doesn't speak Spanish. I should know that. But my brain would play the other way because it got used to that. So we have to be careful with our brains, because our brain will do that in this situation. You're used to the y-axis. You will want to say y equals 3 when you write that equation. But it's x equals 3. So we have to sometimes pay attention. When is our brain playing tricks on us? Okay, so the axes of symmetry, sorry, that was a long story to write x equals 3. Intercepts, we only have a y-intercept. It was at 0, 13/4. You could write the decimal as well, but you'll find that as you get into higher math, fractions are nicer. They're easier to work with mental math-wise than decimals are. So we'll leave it as 13/4. The domain of a parabola is probably the easiest thing to do because it's always everything. It goes on forever from left to right. The range, here I'll put D for domain, R for range. The range is always based on your vertex. Can you see the smallest y value is 1? So we can either write that y has to be bigger than or equal to 1, we can write it that way, or some people like to use the interval notation, saying that it starts at 1 and goes up forever, so it goes from 1 to infinity.